To find the area under the curve, we can use integration, but that's going to tell us a little bit extra, some area that we don't want, right? So we'll want to keep that in mind. We want to subtract this rectangle from whatever result we're about to get. So we're integrating. We want to start at x equals 0, and then to find out where we end, it looks like it's x equals 1, but you'll want to check because the 1 value we know where it's supposed to intersect is when y equals 0.5. So if you plug in 0.5 in for y here, and if you solve that trig equation, you use arc cosine to both sides if you're going to use a calculator, or you could use the fact that cosine is supposed to be the adjacent over the hypotenuse. So we need if we draw this in the unit circle, the adjacent needs to be 1/2. And so 30 degrees always corresponds with the 1/2 angle. So this would be a 60-degree angle. In other words, in terms of radians, this is supposed to end at pi over 3. Okay, so if you check that with your calculator, you'll see why it's close to 1 but not exactly 1. If you do pi over 3, that's 1.04. So I think some students would get this wrong because they integrate from 0 to 1, but you're integrating from 0 to pi over 3. That's for the cosine function. I'm going to use x just because my thetas don't look good with this mouse. And then remember, this would tell us all this area. We need to subtract this rectangle, which is 1 in length, 0.5 in height, so 1 times 0.5. Okay, so that eliminates this area and gives us just the shaded region. So that's this part up here. We want to add the area under the curve over here. In order to make that happen, if we were to integrate the curve here, that's again the cosine function. Let's see. That would tell us the area directly between the curve and the x-axis. So let me get rid of this stuff so I can draw it. So if we were to use integration from our pi over 3 that we found was the intersection point over to where it crosses the x-axis, that will give us this red shaded area. So again, we'll want to use that rectangle trick because we'll do whatever the area of the rectangle is subtracted by this shaded region to get this piece here. So we know it starts at pi over 3 because that's what we just found was the intersection x-coordinate. And it needs to go until we cross the x-axis. In other words, until where y equals 0. And if you solve that equation, find out where cosine is going to be 0, you'll get theta is pi over 2. Again, that's because cosine is the x coordinates in the unit circle. So if you rotate 90 degrees, in other words pi over 2, then you're at 0 on the x-axis. So remember, this is not exactly what we're looking for because this would tell us this shaded region. So what we want to do is we want to take this rectangle, which goes from pi over 3 to pi over 2. So subtract those to find out how long this rectangle is. That would be multiply the top and bottom by 3, so that's 3 over 6 minus 2 over 6. So that's pi over 6 across. This distance is pi over 6 for this rectangle. And then the height, it goes up to 1/2 again. So pi over 6 times 1/2, this is a distance of pi over 12. So this red area needs to be subtracted from pi over 12. And then once you make this calculation, that tells us the shaded region that we want. Okay, getting closer, but now we need to switch back to a regular integral here because it always tells you, an integral always tells you the area under the curve between whatever curve you have and the x-axis. So there's no funny business with this next one. It's just the places where it crosses the x-axis. So at pi over 2. Then we integrate until it gets over here. So where the cosine function is going to be -1, that crosses at pi. And you could do the same thing. You could plug in -1 in for the y value and then solve for theta. But remember, that only tells us this distance to the x-axis. So you'll want to evaluate that integral and then add the other rectangle up here. So to find out how long across that rectangle is, it starts at pi over 2 and it ends at pi. So pi subtracted by pi over 2, that gives us pi over 2. And then the height, again, is 1/2. So the rectangle is pi over 2 times 1/2. So that's pi over 4 for area. Okay, so these are all the things we need to do. This integral, oh, sorry, no, that's good. This integral subtracted by 0.5 plus this, plus this, and plus this, and then we're done.